All right, this is objective 7. We're going to simplify expressions using the properties of exponents. Somebody remind me what properties are. Or what do I call properties? What's a property? Nobody knows what a property is. Caitlin. It's a shortcut. Yeah, it's a shortcut. Things that make life easier. So here is me selling the properties to you. Okay? I always start out with this example. What if I told you, think about how you would work that out. Okay, 7 to the 9th divided by 7 to the 7th. Think about how you would work it out. How many are envisioning a really long problem? Why would you envision a really long problem? Because you would have to do what? 7 times 7 times 7 times 7 times 7 times 7 times 7, 9 times. And then you'd have to do 7 times 7 times 7 times 7 times 7 times 7 times 7, 7 times. And then you would have to take the two numbers and divide them. And tell me about those two numbers after you multiply them all out. They're going to be huge, right? What if I told you I know the answer in my head right now? Would you want to know how I'm doing that shortcut? So that's what I'm going to tell you. I'm going to teach you 5 properties over the next 2 days. I'm going to teach you 2 today and 3 tomorrow. Okay, so we're going to start out with 2 today. But these are shortcuts. I will tell you that with these properties, the shortcuts, you remember I said certain things have to happen before you can use the shortcuts? Like in this case, the bases have to be the same. Are my bases the same? So I'm going to tell you right now, the answer is 49. Okay, and you don't need to write this down by any means. This is actually one of the properties we're going to learn tomorrow. This is just my invitation to you to buy into. I want to know how you're doing that in your head, Ms. Corns. Okay, the base will actually stay the same. What can you do to the exponents? Subtract them. 9 minus 7 is 2, and then you could work that out and get 49. Would you agree with me that that is a lot easier than the first way? Okay, and that's the PEMDAS way. Okay, this is a shortcut. Okay, these are shortcuts that we are learning. So, this is your first property. Again, we're going to be learning 5. We're going to learn 2 today and 3 tomorrow. So we'll kind of do this lesson kind of like a, I actually set it up into Objective 7 and Objective 8 into 2 separate objectives, but it'll be like a part 1 and a part 2. Okay. This one says when we're multiplying the powers and the bases are the same, everybody agree? Bases are the same? You can do what to the exponents? You can add them. Okay, when you multiply powers, you can add them. Notice over here, what do you notice about the base? It's going to stay the same. So here I'm going to tell you a little story. Okay, so all my students that have had me in the past, we talk about, like, normally people want to take the 2 bases and do what to them? They want to multiply them. Okay, so that I get it in your head that we're not going to, you're just going to be working with the exponents. The base will always stay the same. So I always make my class repeat after me, and they always say, base stays the same, and then you say, so today I'm going to ask you, anytime I say the words, base stays the same, I want you to say, base stays the same. And it's gotten to be so that when I walk in the hallways, I had a student yesterday that I had last year came in and poked his head in and said, hey, Ms. Gords. And then he looked at me and he said, base stays the same. I said, base stays the same. And like that's like our code in the hallway. They'll look at me and they'll be like, base stays the same. I'll say, base stays the same. And so we'll try it. I'll see, maybe we can get somebody to drop by here sometime or another, and I'll look at them and I'll say, base stays the same and base stays the same. So anyway, it's just this fun joke that we do. Fun, not fun. Anyway, so, but whatever it is, when I say base stays the same today, I want you to say base stays the same. So here we go. We're going to try it. The base is going to stay the same. Base stays the same. Base stays the same. Okay. So anytime I say that. So let's look at example 1. again, to use the shortcut, the bases have to match. Do our bases match? Yes. So, the rule says that when we multiply powers, the base is going to stay the same. Base stays the same? Aw, y'all let me down. Let's start again. The rule says when we multiply the powers, the base is going to stay the same. Base stays the same. So the base is going to stay the same. And you're going to take the -3 and the 5 and do what with them? Add them. So our final answer will be +2, 7 squared. Am I finished or can I keep going? You can keep going. So 7 squared is 49. So the answer to this one is 49. Okay? If it's a number, you can keep going. If it's x to the second, then you would be done at x to the second. So if it's a variable, you just stop. But if it's a number, you keep evaluating. Okay? How about example 2? Every example I have has a purpose. Anybody want to tell me what they think this might be? I hear, what did Caitlin say? X to the third plus 1? And which would be x to the fourth? Do you all agree with that? Anybody think it's just x to the third? Oh my goodness, y'all are too smart for me. So here's the thought. You know, normally with exponents, we see like 3 to the second power, right? And we know that is 3 times 3, right? Which would be 9. Or we see 4 to the third power, which would be 4 times 4 times 4, which is 64, I think. Okay. What if I just stick a 5 up there? Does it have an exponent? Yeah, every number has an exponent, even if it's not there. You know, we understand these to be positive, right? But the positive sign's not there. We just know that it's positive. Same thing here. Every number has an exponent, and it's understood to be a 1. You need to know that. Most of my students, they'll tell me, they'll be like, oh man, those 1s get me every time. You really need to understand that every number has an exponent. If it's not written, it is a 1. What is 5 to the first? 5, okay? So I agree, this doesn't have an exponent, but it does. It's a 1. Does that make sense? So if it does not have an exponent, you need to add a 1 right there, okay? So I agree, x is going to stay the same because, watch this, Miss Handy, base stays the same. See? Base stays the same. So 3 plus 1 is 4. Okay, and it is x to the fourth. Any questions about the 1? Never says, oh, wouldn't we love it if our SOL questions were like example 1 and example 2? Wouldn't that be great? Here's what I'm here to tell you. It's going to look like this. This is what your SOL questions are going to look like. Okay? Everybody says, that's just too much. Well, not really. What we're going to do is we're going to take our problem and we're going to organize it. Okay? And I'm going to take you back. I'm going to use my son Reed as an example. And again, I don't mean to talk kindergarten to you, but that's how I understand algebra. Okay? It's just like sorting things. That's what you did in kindergarten. Like if I laid out a bunch of crayons and I said, Reed, I want you to sort these for me. What would he do? He'd take all the yellow ones in, put them in a group, and all the blue ones in, put them in a group, and all the red ones in, put them in a group. What if he had 3 yellow, 5 blue, and only 1 red? What would he do with the red? Will he put it with one of the others, or will they just put it in their own group? So they just put it in their own group. So that's what we're going to do here. We're going to just sort our numbers with our numbers, our x's with our x's, our y's with our y's, and our z's with our z's. You follow? So I'm just going to sort everything and put it, group it. Okay? So I'm going to put the 3 with the -4, be specific. I'm going to put the x squared with the x. Anything I need to do to that? Should I put the 1? Well, you don't need it, but here's what, until you get used to it, I would definitely put it, because why? People will forget about it. So I'd put the 1 until you get used to it, okay? And y to the third with y to the 5th and z to the fourth with z squared. Now it looks a little bit easier because things are grouped together. Does that make sense? Things are grouped together. So now we're just going to work it out. 3 times negative 4. Now my question is do we add? A minute ago when we multiplied powers, we added. But we added what? The exponents. If these are just plain old numbers, you with me? Treat it like normal. If it says to multiply them, then you multiply them. Does that make sense? So numbers are like in their own little category. You treat them like normal. The properties and the shortcuts happen when you have variables that have the same base and you can add the exponents. So 3 times negative 4 is negative 12. X to the second times x to the first. When you multiply powers, we add the exponents. Y to the 8th and z to the 6th. Any questions about that? Am I finished? Can I add these? Why not? The bases are different. Again, you can only combine them when the bases match. Okay? So I'm done. The answer is negative 12, x to the third, y to the 8th, z to the 6th. Any questions about that? Okay. So if we look at example 4, I'm going to let you write it down. Then I'm going to let you try it out. What looks confusing about it? The f is negative. So here's my thought. Normally when we have variables, like over here, I have a 5f, right, in the beginning, or 5f squared to be specific, okay, but I have a 5 in front of the f, okay, or we have, like normally we have like a 3x, or a 8y, everybody agree? What if I just put an a up there? How many apples do I have? I have one a. One times a is the same thing as a. Everybody agree? So when I have a negative a, tell me how many negative apples do I have? I have negative 1 apples. So what I want you to understand, and again, here's where everybody goes, oh, those ones get me every time. There's 2 types of ones you need to know that are there. If it doesn't have an exponent, right? If there's no exponent with it, it has a 1. If there's no number in front of it, it has a 1. So this is a negative 1f. So could you sort them now? I want you to take a minute and see what you can do with this. Put your numbers with your numbers, and your f's with your f's, and your g's with your g's, and your h's with your h's. Okay? And see if you can work it out. What will I group together? 5 and, more specific, negative 1 and f. Be very specific, guys. F to the second times f to the first, right? This has a 1 with it. Okay, then anything with the g squared? Now again, remember when I said Reed's crayons? If he only has one red one, he doesn't put it with the blue or the yellow because they don't match, right? It makes its own little pile. So same thing, if you only have one thing, it just makes its own little group, okay? And then h to the 6th times h to the 2nd. And when we sort, there is a proper way to sort. How are we sorting? The first thing is your numbers, and then how do we sort after that? Well, left to right, and it does go in order, but alphabetically. So does that make sense? A, B, C, D, E, F, G, H. Yes, I do have a story of the day for y'all. I didn't tell first block. It just made me think with my F's. So when I was grading papers last night, Chance looked over at me, and he said, you know, what did that student make? And we talked. He said, now is that a B or a C or a D? He's like, Mom, what are your grades? Because you know they have like E's and G's and S's and stuff like that. And I told, so I explained our grading thing, and he's like, you skipped one. And I was like, because we go A, B, C, D, and then we go to F. He's like, you skipped one. He's like, y'all should so have an E. Extra bad. Anyway, I thought it was funny. I was like, that makes a lot of sense there. He's like, so we should add in an extra there thing. You're extra bad if you get an E or something. I don't know. But anyway. Okay, so when we multiply these, -5, F to the 3rd, G to the H to the 8th. Any questions? How many got that? Cat dog. Any questions? Okay. Here's your property number 2. Okay. We're only learning 2 today, so we're half done. Any questions about when we multiply the powers, we add the exponents? This power, you need to understand what you're looking at. Like, you need to understand when they're being multiplied. Oh, they're being multiplied, so I'll add the exponents, okay? This one, it looks like we have a power. Everybody agree we have a power? And then what are we going to do? We're going to take it and raise it to another power. We call this raising a power to a power. You've got an exponent, and yet you're going to raise it to a second exponent, okay? A power to a power, okay? What will we do to the exponents? Thompson, what do you know about the base? Base stays the same. Base stays the same, okay? The base will stay the same, and you'll simply multiply the exponents. And you know how I remember this? Here's the thing. Everybody's like, this isn't too difficult. When does this get difficult? We're going to learn 5 properties, and what do people do? They mix them up. It's like, what do you do during what property? And most of the time, people, when you're multiplying powers, what do they want to do? They want to multiply the exponents, okay? It's always, you know, something than whatever you would think it would be. Like when you multiply the powers, you don't ever do what it says. You don't multiply the exponents. You actually end up adding them. Can I really quickly, I know I'm jumping back, can I tell you why we add them? We know the answer to this would be what? X to the 5th. Tell me this. X squared is X times X. X to the 3rd is X times X times X. What's another way to write that? There's 5 of them. 1, 2, 3, 4, 5. X to the 5th. Do you see why we add them? There's 2 x's. There's 3 x's. So altogether you got 5 total. Okay, that's why you end up adding them. Okay. Here though, this is how I remember raising a power to a power and you multiply. Anytime we have a set of parentheses and a number on the outside, what are you going to do? You're going to multiply. What if there's more than one thing in there? You're going to multiply it to everything, just like what? Just like our distributed property. Does that make sense? Anytime you have a set of parentheses and a number on the outside, I don't care if it's just normal distributed property or if it's this property, raising a power to a power, you will distribute everything in and you'll multiply. You multiply every time. That's how I remember it. Okay, anytime you have a set of parentheses with the number on the outside, you multiply to the inside. Okay, so let's look at an example. Who wants to offer me an answer? Austin. 5 to the 12th? Do we agree? I agree. Why don't we take the 4 to the 5? Because the base stays the same. Base stays the same? Good. Okay, the base is going to stay the same, and you simply will multiply the exponents and get 12. Okay, now the question is, could you work that out further? 5 to 5 to 5 to 5. But what do you know about it? It's going to take us a while, and it's going to be huge. So here's my rule for you. And this is normally if it's a number, you keep on multiplying it. But here's what I'm going to tell you. This is Miss Corn's rule. This is not a rule, like a certified rule or anything. This is just what I tell you. It's kind of, I want you to remember kind of like rounding. Everybody agree if something's to the 5th power, the 6th power, the 7th power, that's going to take us a while, right? So if it's above 5, if the power is above 5, you can just leave it, okay? If it's 4 or below, to the 4th power, to the 3rd power, to the 2nd power, that's not that big, right? I want you to go ahead and multiply it out. So if it's 4 or below, it's kind of like rounding, I want you to go ahead and multiply it out. But if it's 5 or higher, that's going to be a long time, and that's going to be hard on you, so you can just leave it if it's 5 or higher. So I'm just going to let you leave that, 5 to the 12, okay? And then we all say, thanks, Ms. Corns, for not making us multiply all that, because I could, right? I could say multiply 5 times 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 5. No, we ain't doing that, okay? Somebody different, offer me an answer. All right, Colb. Everybody agree? A to the 6th. Any questions? Can you work that out? No, why not? Because it's a variable. Again, if it's a variable, you can leave it. If it's a number that's to the 4th power below, I want you to go ahead and work it out. Okay? So, you try example 7. My question is this one that I want you to go ahead and multiply it out? Yes, why? Because it's below 5. Yeah. So what do we get when we multiply it out? Somebody different. Somebody besides Caitlin and besides Colby and somebody different. Uh-huh. 81. Very good. This becomes 3 to the 4th. Base stays the same. And 2 times 2 is 4. And then go ahead and multiply. That's not that big of a deal. 3 times 3 times 3 times 3 is 81. Any questions on that? And you can sit there. How many did this? 3 times 3? 3 times 3? And then 9 times 9? It's okay. I don't expect you to do it in your head. So write it out. It'll be okay. But you're getting a calculator later, so you can use that too. Okay? Now, wouldn't we love if our examples on this property on the SOL were like examples 5, 6, and 7, right? We'd love that. But they'll probably look more like examples 8, 9, or 10. So what do you do? This is like a power to a power to a power. Somebody different want to offer me an answer? What's Logan got? How about Tanner? 7 to the 18th? Agree or disagree? Agree. So basically you're just going to multiply all those. 3 times 3 is 9. 9 times 2 is, and what do you know about the 7? Stays the same, because the good. Any questions? Is this one I want you to go ahead and multiply out? No, it'd be humongous, so just leave it, okay? So, here's what I'm going to tell you. You're going to work these problems like an onion, okay? You always start at the inside first, right? So tell me this. Does anything match on the inside? If you could, you do something on the inside. And so I'm going to remind you of that because eventually, will you be able to do something on the inside? Yeah, so you work the inside first. If nothing matches, everybody agree? You got a number, an A, a B, and a C. Nothing matches. If you could, you would, but we can't, so we're not. Okay, now we're going to go to the outside. Okay, so when I go to the outside, what am I going to do with this 3? Good, y'all listen to me. It's like the distributive property. You got to multiply by all. So be very careful. Tell me one thing 3 goes to. It goes to the 4 that's with the C. It goes to the 2 that's with the B. It goes to the 1 that's with the A. Oh, I loved how she said that. Because number one mistake, it does go to that -3. But you know what people do? They take 3 and multiply it by and get -9. That's not going to be the right answer. Okay? Well, how did she say it? It goes to the 1 that's with the 3. So you're going to multiply the exponents. What do you know about this -3? It's going to stay the same because the base stays the same. You need to tell yourself that when you're working your problems, okay? You only work with the exponents. The base will stay the same always, okay? So -3 is going to come down. How does this go to each one of them? What are we going to do? Add, subtract, multiply, divide? We're going to multiply, right? Anytime you distribute, you multiply. So 3 times 1 is 3. And here's what I'm going to tell you. There's something very important about this. What do I need to do with the -3? You need to stick parentheses around it. Here's what I'm going to tell you. When we get our calculator, and I'll show you this in your calculator, but watch this. Tell me this. Would these be the same answer or would they be different answers? Yeah, just because I'm going to tell you they're different, just because you think I'm going to say they are different. Okay? So here's what I'm going to tell you. This one right here, if you just stick in -6 squared, it's going to square the 6, and what do you do with the negative? You drop it, and you get -36. And that's not what you're going to want. When you're going to square something, you've got to put parentheses around it, because what's that going to do? This means to square both the negative and the 6 and do -6 times -6, which gives you a positive. So here's what I'm here to tell you is, did you ever see the difference? This one, again, like if I gave you something like this, like 3 minus 6 squared, what would you do? You would square the 6 and then drop the negative, right? Does that make sense? Like if I gave you that problem? So without the parentheses, you just square the 6 and drop the negative. But with the parentheses, you actually multiply the negative with the negative. And so that will change your answer. So make sure you put parentheses around it. Okay? This will become a to the 3rd, b to the, and c to the 12th. Any questions on that? Am I finished? I heard yes, I heard no. Is there anything left up there that I could keep evaluating? Can I do -3 times -3 times -3? Yeah, I can work this out. Can I work any of the rest of this stuff out? No, because those are variables. But I can do -3 times -3 times -3. -3 times -3 is +9. +9 times -3 is -27. A to the 3rd, b to the 6th, c to the 12th. You are finished. Questions? All right, you try example 10 on your own. Can you do anything on the inside? I want to remind you of that because, again, eventually you will be able to do something on the inside. But you got a 5, you got an R, you got an S, you got a T. None of them match, right? You can't do anything to this. So then we go to the outside. What can I do on the outside? I can distribute. So this goes to the 7. What else? To the 6 with the S. What else? The 1 with the R. What else? The 1 with the 5. Yes, very good. And so the 5 stays the same. 2 times 1 is 2. Number one mistake, and this will be one of, you know, those distractors on the SOL or on the IA test, the things they like anticipate you doing wrong. I guarantee somebody, one of the answers will have what in front? What number? 10. How? Because they do 2 times 5. They take it to the 5. Make sure the base stays the same and you take it to the 1. Okay? 2 times 1, R to the 2nd, 2 times 6, S to the 12th, 2 times 7, T to the 14th. Am I done? What can I do? 5 times 5, which is 25. R squared, S to the 12th, T to the 14th. How many got that? Anybody have any questions about that? Again, the number one mistake here is either one of the distractors will have a 10 in front. And so either you accidentally do 2 times 5. One of the distractors, it'll just have a 5 in front. Because what do people do? They forget to, they take it to all the variables, but then forget to take it to the number. Does that make sense? And then another one is maybe instead of multiplying, it'll have them maybe adding or something like that. Okay? All right. Last example that we're going to work on today. And everybody says, oh. I'll let you write it down and let you kind of digest it for a minute, and then we'll look at it. How many properties do you know thus far? 2. What's one of them? The one where you see a number on the outside, and you raise a power to a power, and you multiply it to everything on the inside. That's one. And then the other one is when everything's being multiplied, you add the exponents. So which ones do you see up here? Both. Very good. Everybody agree? We see the first one being raised to the 4. Okay. And so the 4 is going to go to everything. And then both of these are side by side, so they're being multiplied. The question is which one do you do first? So again, here's your onion. You go inside first. Can you do anything on the inside here? Anything match here? No. Anything match here? No. From there, you go to the outside of the parentheses. What's on the outside? The 4. So you're going to work that first. That's going to go to what? The 1 that's with the -2 with parentheses. It's going to go 1 with the X, the 2 with the Y, and the 3 with the Z. Does it go to this one over here? No. So what are you going to do with this one over here? Just bring him down, right? Just leave it. Okay, so I want you to do that. Evaluate the 4 first. Bring your answer down, bring the second one down, and then what will you do after that? You will do you'll group it and add the exponents. Okay, so see what you can do with it. You'll group it and add the exponents. Anybody want to offer me a final answer, and I'll give you a piece of candy if you get it? Oh, oh, oh. What's Caitlin got? Okay. Okay. Any others? Go, Austin.
-24, x9, y10, and z12.
Make sure you say it properly. X to the 9th, y to the 10th. That's just me being particular. Okay, got 2 for that. Any others? Tanner? That's okay. That's what I need to know. You got 48? -48. Okay. Any last minute? We'll work it out and see who's right, see if anybody gets candy. Any others? Lindsay? Okay, so we get a +48, x to the 9th, y to the 10th. Anybody like one of those or any of those? You like the second one? So if y'all get that, I'll give both of you a piece. Okay, but we'll see. Let's see who's right. I think I see a correct answer up there. Here we go. Does everybody understand? I'm going to take the 4 to everything at once. So this is going to become -2 in parentheses to the 4th power. 4 times 1 is 4. X to the 4th, 4 times 1 is 4. Y to the 8th, Z to the 12th. Everything else is going to come straight down. Now before I group, is there anything that I can work out? Oh, they said we got it wrong. So we'll take this one out. We're working our way down. Does everybody agree? Before I keep going, let's go ahead and work this out. If there's something you can work out, let's work it out, okay? So this is -2 times -2 times -2 times -2. Everybody understand? You got to do the negatives with it. A negative times a negative is a +4. A -2 times a -2 is a +4. And 4 times 4 is 16. X to the 4th, y to the 8th, z to the 12th. Does that make sense? Yes? Does everybody understand how I multiplied all that? You could do, if you'd rather do it, you could do it like this. -2 times -2 is +4, times it by -2. 4 times -2 is -8. -8 times -2 is, you still get +16 either way. Does that make sense? Okay, so from here, everything's just being what? Multiplied, right? So you got to know your rule. It's all being smushed together. There's no sign, so let's group it. I'm going to group the 16 with the 3. I'm going to group the x to the 4th with the x to the 5th. I'm going to group the y to the 8th with the y. And I'm going to group the z to the 12th by itself. And when we multiply powers, we add the exponents, okay? So 16 times 3 is 48. This becomes x to the 9th, y to the 10th, z to the 12th. Do we see a correct answer up there? Who gets candy? Lindsay! Good job. Okay, very close, very close. Does that make sense, the positive? Okay. And everybody got the variables right. It was just that number in front. Any questions? Is that better? After I explained it? So one piece at a time. Okay. Always work inside the parentheses first. Then you go to the outside. So we went to the outside. Distributed that in. And then from there, once we get down to here, everything's just side by side, so it's being multiplied, so then you group them and add them. Okay? All right, we're actually not going to do that practice.